What is the cheapest way you can run a full stack application in the cloud? In this video, I'll show you how to run an application with React, .NET and Postgres in the cloud completely for free. Let me set the scene for what the full stack application looks like. I have an ASP.NET Core 9 API with a single controller that exposes a set of CRUD endpoints on the product's resource. So nothing out of the ordinary here, just fetching some data from the database, being able to create a product, update it, and delete it. The product itself is a fairly complicated model with a bunch of nested types inside, so this is going to be interesting to display on the user interface. When running locally, this is using Docker Compose with a Postgres database so that we actually have some data to work with. So let me start the application. And then I'm going to head over to the client application, which was built using Next.js, which is a React framework. So this is essentially a React application acting as our client and is going to expose a few simple pages where we can interact with our API. This particular page here is going to list the details for a product with a given identifier. We also have the default page, which is going to list a set of products, and the way to start this application is by using the CLI, and the command I'm going to use is npm run dev. So this is going to start the React application, or the Next.js application to be more specific, on localhost 3000. And when I navigate to localhost 3000, this is the screen that I see, and this is actually communicating with my API running in the background. So I have 3 products at the moment. I can click the Create Product button to scaffold some dummy product data, which I can send to the API in the post endpoint, and this is going to generate a new product. I can also delete a product and is going to remove it, and I can also take a look at the product details, which is just going to list what we stored in the database. From this screen, I can also delete the product, and of course paging works as expected. So our goal now is to get this deployed to the cloud completely for free while running a React application, an ASP.NET Core Web API, and a Postgres database. And I'm going to show you how you can achieve this using Azure and an additional service to run the database. So let's start from our front-end application, the Next.js website. Azure has a Static Web App Service, which we can use to host static applications. Next.js by default does require a server, but I configured it to be a completely static website, so we can host it here without any problems. In general, Azure Static Web Apps also support Next.js. So let me create a new static web app. I'll use my existing resource group, and I need to give my web app a name. So I'm going to call it the products client, and I will be using the free plan, which does come with some limitations, but it's definitely going to be all you need for simple projects and small applications. So let's take a look at the next step, which is the deployment details. I'm going to click Other because I will be deploying this application myself. There are also integrations with GitHub and Azure DevOps where you can connect your repository and is going to configure a CI/CD pipeline to help you deploy this application. But as I said, I want to do this myself. So let's click Next. I don't need anything from the advanced section. I'm going to leave the tags empty and I can go ahead and create my static web app. So let me hit Create. This is going to take some time, and in a couple of moments we're going to get our static web app. So I can go to the resource, and currently there is nothing here. So how do I actually deploy my application from my local machine into the Static Web App Service? There is a button here called Manage Deployment Token, and I can go ahead and copy this value, and I'm going to use it to deploy my Next.js application from the CLI. So let me stop the local server and clear the screen, and I'm going to make this just a bit larger so that you can actually see the commands that I'm using. So Static Web Apps already has a CLI that you can use. I installed this ahead of time, and the command to use this is SWA, which stands for Static Web Apps. So the first thing you have to do is initialize your application with Static Web Apps by calling SWA init. Now, if I do this, it's going to allow me to pick a name for my configuration. It's then going to detect that I'm running a React application, which uses Next.js, and is going to set up some default values. Now, I can say that these settings are correct, but I already initialized this project ahead of time, so I'm not going to override those values. Now, let me show you what I have configured here. This is the file that is going to create, and the only change I made here is the output location. By default, it's going to be .next, but I changed it to be the out folder, which is where my static website is going to be built. Now, this is also made available by updating the next config, and I set the output to be export, and this generates a static website. We're going to take a look at this a bit later when I deploy my API, but essentially I'm providing the API URL through an environment variable. But let's go back to deploying our application. The next thing I have to do is build the application. So I'm going to say SWA build. This is going to take a couple of moments, but in the end of it, I'm going to have my application ready that I can now deploy into the cloud. You can see the pages that were generated here. And now the next command that I need to run is SWA deploy. I'm going to specify that it's going to deploy from the out folder, but if I want to, I can omit this because it's specified in my configuration. The next thing I need to do is provide the environment, which is going to be production. I'm just going to deploy straight to production. By default, it's going to deploy to a preview environment where you can review your application before promoting it to production. And then I need to specify the deployment token, which I copied from Azure. So I'm going to paste that in and let's deploy our application. So now this is going to take a few moments. It's going to zip up the application files and upload that to Azure. And in a couple of moments, we'll be able to access our Next.js application hosted as an Azure Static Web App. And when this completes, we're going to get the link to the Static Web App instance. So I'm going to click this link and it's going to open my React application, which already has HTTPS configured. And currently you can see that it's not working because we don't have our API. So let's fix that part next. I'll go back to Azure. And the service that I'm going to use for hosting my .NET application is going to be the Azure App Service. So let's go to App Services and I'm going to create a web app service. Let me choose the same resource group as our static web app. Then for the name, I'm going to pick Products API. I want to deploy this from my code, although you could deploy a container, which is probably what you want to do for production, but this is going to be simpler. So let me pick .NET 9 as my runtime stack. I want to run this in Linux, and I'm going to host this in a location close to me. I'm going to pick Germany West Central. This is going to create a new pricing plan, and I'm going to change the plan to be a free instance of the Azure App Service. You get a pretty limited amount of compute, just 60 CPU minutes per day, but this could be more than enough for very simple applications, and it's free. The next level up is a basic instance, which is about $13 a month. The one advantage of the basic instance is that you can have it always running, which is good if you have some background jobs. With a free instance, it's going to shut down if the API is idle. So let's pick the free instance nonetheless. For the database, I don't want to choose anything. I'll be providing my database separately. For the deployment, we already said that we don't want to use continuous deployment. For the networking, I want to enable public access because this will be used by my React application. For the monitoring, I'm going to turn off application insights by selecting no here. I don't need any tags. And then let's go ahead and create our Azure App Service. And while this is initializing, let's talk about the database. There are two popular services that you can use for getting a small Postgres instance completely for free. The first one is Supabase, which you can see here. So from the Supabase dashboard, I just need to create a new project and give it some name. So let's say this is the products catalog. I'm going to generate some strong password that I will use to connect to the database. And let's pick the Germany data center for hosting our database. So I'm going to create this. After a few moments, our Supabase project is ready. And I can go ahead and look at my database from the database page. Now here, you can see that our database contains a couple of default schemas. Let's say the auth schema with the default tables needed for user authentication. But what I'm interested in is connecting to this database. So I can click on the connect button and here I can choose how I want to connect to the database. So let's pick .NET and this will give you a couple of connection string formats that you can use for connecting to the application. Now I'm going to pick the session pooler because it's IPv4 compatible. The direct connection is currently using IP version 6 and I was seeing some issues with the MPG SQL driver when using this connection string. So I'm going to use the session pooler approach. Now other than Supabase, there is another service that you can use. It's called Neon. You can also get a free Postgres instance. And the advantage with Neon is it comes with branching out of the box. So you can literally create a separate branch of your database. And for example, you could have a dedicated branch for each developer and each branch contains a copy of the main database. So how you create one is by giving your project a name. So let's again call it products catalog and the database name will be product. Let's pick Azure as the data center, and I'm going to choose Germany West Central to keep the Postgres instance closer to my API server. So I can click Create Project, choose my auto scaling option, and I can create the instance. From the dashboard here, I can obtain the connection string. So if I go to .NET, I'm going to get the connection string format that I can use inside of my .NET application. So this is how you can use a Postgres database with Neon. Now I'm going to be using Supabase for this example, but I also wanted to highlight Neon as another option. Now let's go back to Azure, and my app service is ready. So one thing I'm going to do is update the environment variables. I'm going to click add, and then the environment variable name is going to be connection strings, 2 lower dashes, and then database. And then I'm going to add the connection string value from Supabase and click apply and save these changes. Now let's head into Visual Studio to actually deploy our backend application. To deploy your application from Visual Studio, you can right click your project and then click Publish. This is going to start the setup for your Publish profile. Now I'm going to choose Azure as my deployment target, and the service I'm using is going to be an Azure App Service running on Linux. So let's click Next. This is going to find my resource group and then the app service that I want to deploy to. So I'm going to choose Products API. I'm going to skip API Management, and then let's deploy this by generating a Publish profile. So I'm going to click Finish. This is going to generate a published profile, and after that's done, I can hit publish, and if the build passes, it's going to deploy the application. Remember that we already configured the connection string to our database as an environment variable, so when this is deployed successfully and it starts, it's going to automatically apply the database migrations. You can see our deployment goes through successfully. So now I'm going to update my React application by specifying the backend URI, and I'm just going to redeploy it. So I'm going to say SWA build to build my React application. This is going to complete fairly quickly, and then I'm going to deploy it. Our build completes, so let me clear the screen, and then I'm going to find the deploy command and execute that, and this will deploy my React application with the proper URI for the backend configured. And if I go ahead and refresh my client application, the error is gone. If I try to create a new product, you will see that this succeeds. I can create another one, I can refresh this page, I can go ahead and delete a product, and I can also visit the product details where I can see what we have in the database. And we are fetching all of this from the API instance running as an Azure App Service. If I check out what we have in Supabase, you can see that I have the products table and the EF Core migration history table, and here is the one product that I left in the database with the information inside. If you're wondering how this is working, when my .NET application was starting up, I automatically applied any pending EF Core migrations. So make sure you smash the like button if you enjoyed this video. And what we could do next after manually deploying our applications is automate this in a CI/CD pipeline. For the app service, you can download the publish profile from here and then deploy it with something like GitHub Actions. And you already saw how to use the CLI to deploy the Next.js application. You can just run this as another GitHub action. None of this is too complicated to implement. But if you don't know how to get started, here is a step-by-step guide of how you can build a CI/CD pipeline completely from scratch. Check out my courses if you want to improve your software architecture skills. If you want to grab the source code for this video, it's going to be in the description right below. Thanks a lot for watching, and until next time, stay awesome.